Isomerism in organic compounds. Isomerism is a phenomenon in which the compounds possess same molecular formula, but they differ in their physical and chemical properties. Okay, they differ from each other in their physical and chemical properties. Okay. Physical and chemical properties. And those compounds are called as isomers. Okay, compounds are isomers. This isomerism is divided into two. Structural isomerism and stereoisomerism. Okay, these are the two types of isomerism. Okay, let us discuss one by one. First, structural isomerism. What do you mean by structural isomerism? Structural isomerism. Structural isomerism is a phenomenon in which the compounds are having same molecular formula, but they differ in their structural formulas. Okay, same molecular formula, but different structural formula. Okay, and they are divided into four. The structural isomerism is divided into four. Which are they? Let us see one by one. First one is chain isomerism. Okay, and the second one is positional isomerism. Third one is functional isomerism, and the fourth one is metamerism. Let us discuss one by one with suitable examples. First one is chain isomerism. Chain isomerism is also called as nuclear isomerism. Okay. Now let us see one by one. First one, chain isomerism. Chain. In the case of chain isomerism, this isomerism arises due to the difference in the structure of the carbon chain. Difference in the structure of the carbon chain. Okay. Let us see with examples. Take examples. CH3, CH2. We can call them as normal pentane. Okay. And take this example. In the second position, a CH3 group is attached, but their molecular formula are same. Okay. These compounds are having same molecular formula, but they differ only in their structure. So such compounds are called as, this is named as isopentane. These compounds are called as chain isomerism. The chain isomers, and this phenomenon is called as chain isomerism. Okay. Now, next, second one is position isomerism. Positional isomerism. this case, the phenomenon in which the compounds are having same molecular formula but they differ due to the change in the position of the substituent atom attached. Differ in the position of the substituent atom, or the functional group, substituent atom or functional group attached. Group attached to the carbon chain. Okay. Take one example. CH3, CH2, CH2OH. Okay. CH3, CH. Here the OH group is attached. So the position of the OH group is different. So such compounds are called as positional isomers. Propan 1-ol and propane 2-ol. Propane 1-ol and propane 2-ol. This is the second type of isomerism. Now the third one is positional. Next one is functional isomerism. Functional isomerism. In this case, those compounds, the phenomenon in which those compounds are having same molecular formula but they differ in their functional group. Same molecular formula but differ in their functional group. Take suitable example. They have the molecular formula same. So CH3, C double bond O, CH3. The functional group is a keto group. Okay. Now CH3, CH2, CHO. Both are having the same molecular formula and the compounds are propanol and propanol. Okay. So both the compounds are different in accordance with their functional groups. Next, third one is metamerism. Fourth one is metamerism. In this case, those compounds which are having the same molecular formula but they differ due to the unequal distribution of carbon atoms on both sides of the functional group. Unequal distribution of the carbon atoms. On both sides of the functional group. Take one example. C4H10O. Example. We can write this in two ways. CH3O, C3H7. Okay. Also this is an ether. Also C2H5O, C2H5. Both are having the same molecular formula but unequal distribution of carbon atoms on the two sides. This is called metamerism. Okay. This much about structural isomerism. Now the next division is, next one is stereoisomerism. This is the phenomenon in which the isomers are formed due to the different arrangement of atoms, different arrangement of atoms or groups, different arrangement of atoms or groups in the space. Or they have different spatial arrangement of atoms. This arises in the case of those compounds having the double bonds. Okay. These are of two types: geometrical isomerism, and second one is optical isomerism. Okay. Optical isomerism. In the case of geometrical isomerism, the compounds are having the different spatial arrangement due to in presence of the double bonds. And in the case of optical isomerism, this is due to the presence of asymmetric carbon atom. Asymmetric means those compounds, those carbon atoms containing different, all the 4 atoms attached to the carbon atom are different. This much about the isomerism.